Okay, good morning. Can you hear me okay? No? Oh, is the mic on?
Wait for a second, let me see. Where's your pack?
It's over here.
Yeah.
Okay.
No, he needs to be turned on.
Ah, okay.
Hold on, I'm gonna rearrange this for you. That was like an angelic pose.
Yeah, that's what I'm going for. Is that better? Great.
Is it good? Does anyone need him to be louder? Raise your hand if you need him louder.
Can you hear me now?
Say something else.
Something else. Good morning. 1, 2, 1, 2. Hello. Maybe I'll just talk a little bit louder, yeah. Right, so thank you, Aaron, for that kind introduction. I'll do my best to live up to it. It'll be a hard task, but okay, let's talk about everyone's favorite API. The directive system in Angular is probably what brought most of us to Angular. It's kind of the thing that gives us this superpower of being able to extend HTML to our needs. And that's something most other frameworks still don't do. It's just a little bit of a problem that it's wrapped inside this thing that most of us have a lot of trouble learning as we're learning Angular. And to be honest, some people, including myself, have some trouble with it when we're supposed to have learned Angular already. So it is a difficult API. Actually, how many people here feel like they know this API, all the configuration options here, and everything they do, like exactly? There's a couple of people over here. So to you people, congratulations. To everyone else, make note of who just raised their hand, because you can ask questions from them later. But so what I'm going to do today is try to get us on a path of a sort of deeper understanding of this API by looking into the implementation of the directive system, sort of behind that API, and kind of understand what it's doing for us behind the scenes. And speaking of the implementation of the API, or the directive system, you'll actually find it all in this single file in the Angular code base called compile.js. So everything there is to know about Angular directives will be in that file. So if you want to learn it, you can just open it up and see what's inside. Right, so this is not going to work. This is not an easy piece of code to approach. Like if you're trying to learn how this works, how do you even start? Where do you begin? To look for the things you're looking for and figure out what it's doing. And so what I'm going to do today is actually two things. I'm going to first of all narrow things down quite aggressively to a few core features that are in that file, mixed with everything else that I think form the core of the directive system. The other thing I'll do is actually flip things around a bit and not try to explain what's in that compile.js file currently, but to actually write our own little version of the compiler that mimics the real Angular compiler, and in the process kind of build up our own mental model of what it's doing. So those four things that we'll look at are the DOM compilation that happens when Angular starts, and the linking process that goes into it, and the scope inheritance management that's done during that, and the management of isolated scopes and isolate bindings that happens there. So that's our roadmap for this morning, and let's go right ahead and take a look at the directive system then. And the first thing we'll look at is the actual compilation process that the directive compiler does. We should probably define this term first, because it's kind of one of those things that can mean so many different things. What does it mean to compile something? In Angular, what we mean by compilation is this process provided to us by this $compile service that has certain inputs and outputs. So the inputs to that process are a collection of directives that you register to your app and a piece of DOM that you want to apply those directives to. And what compile does, it combines those two, applies those directives to that DOM to produce this mutated DOM. That's what compilation means in the Angular context. How that looks like in code is that you have this compile provider into which you can register directives. And you can do it by providing a name for the directive and a factory function for it. And that factory function then returns the actual directive object. So here we have one that actually has just one configuration option on it. It's the compile function, which can do whatever it needs to do for that directive. This example just adds a CSS class to an element, but it could really do anything to decorate the element or extend it or add behavior to it. Then you have some DOM on your page, which you want to apply those directives to. And what you do is you grab that element from the page, you wrap it inside this Angular element, and you give it to the compile service. And it will then apply those directives that you registered to that piece of DOM. And what you end up with is this mutated version of the DOM, which is the result of those directives having done whatever they do. So how might we build something like this? Well, we're going to need this compile provider into which we can register directives. It has this method called Directive, which we already saw in action, that takes two arguments, the name of a directive and a factory function for it. And what it does is it puts those things into this internal storage it has inside this provider, this object here. And one thing about this is that in Angular directive names are not unique, so we need to support the fact that for each name there may be several directive factories. So what we have here is actually an object in which the keys are directive names and the values are arrays of directive factories. Also, the directive factories support dependency injection, so we need to plug that in here as well. So we'll use the provide service to do that. We'll inject that into the provider. And then as we see the first directive for a given name, we actually register into the application using the provide service a regular factory function by the name of that directive followed by the string directive. And that factory, when it's called, will instantiate all the directives with this name. And it'll do that by first looking up those factories from this internal object that we have here, and then invoking all of them with dependency injection support. So for that we need the injector, and what we do is we map over those directive factories with the invoke method of the injector, and that actually instantiates those directives, calls those factories, providing them any dependencies that they need. And the result is an array of directive objects. That's what this factory provides. So then when we have this registration done, we can move on to make the actual compiler. So we're building a regular Angular provider here, so it has this get method on it, and that returns the actual thing that we're making, which is compile. So this is what you actually get when you inject $compile into your application. It comes from this provider here. So then we can talk about what that function actually does. Its job is to compile an element. And to do that, it actually, well, first of all, delegates pretty much everything to this helper function called compile node. And this is a function where most of the interesting work will happen today. To compile a node, the first thing that we need to do is figure out which directives should be applied to that node. And to do that, we introduce yet another helper function, actually, called collect directives. And its job is to give us an array of any directives that we know about that should be applied to this element. And we can find those kinds of directives using three different strategies, which are, first of all, to find them matching the element's tag name itself, or we can match them using the element's attributes or attribute names, or we can do it matching the element's CSS class names. So what we do is we try all of those three strategies and return this combined result of all of them. And how we actually do that matching with these three helper functions. First of all, to match directives to an element by its tag name, we first figure out what its tag name is. We can get it from the DOM using the node name standard attribute. That's going to give us an uppercase hyphen separated string. Our directive names are camel case, so we can use Lodash to produce a normalized camel cased version of that element name. And then we still form this kind of full directive name with the suffix, because that's what we used with the injector. And then we can check, do we have directives matching this element's name? So we have this directives object in scope of this provider, so we can just check, does it have a key matching this normalized element name? And if it does, we get the corresponding directives from the injector with that full directive name, and that will call the factory that we set up a few minutes ago. And we need to get the injector to do that. And that returns us an array of directives, one or more of them. Or if we don't have any matches, we just return an empty array so that we have, in all cases, something to return. For attributes, we repeat pretty much the same trick. We just need to have a loop over the attributes because there may be any number of them on an element. But we go over the attributes, each of their names we camel case, and then check if we have matching directives for that camel-cased attribute name. And if we do, we instantiate them using that injector, the factory we put into the injector. And we combine the results all into this single array and return it. And that gives us an array of all the directives that match any attribute names on this element. Then for CSS class names, we again repeat the exact same trick. We loop over the DOM class list of this element, which gives us a collection of the class names. Each one we camel case, check matches for in the directives object, and if we find any, instantiate them, put them into this combined result array, and return it. And when we're done with all of that, we have found all the directives that we should match to this element. And what's then left to do back in compile node, where we have this array now, is to actually apply those directives to the element. And that can be done simply by having a loop over all of them that we found and calling for each one the compile method. So this is where the directive gets to do whatever it does, whatever it has defined in its compile method will get executed for this element at this point. And that pretty much covers the compilation of a single element. But before we are done with compilation, we should talk about the fact that when you actually give an element to the compile service, you don't expect it to just compile that single element, but all of its descendants as well. So we need to actually go into the child nodes here as well and compile them too. That's actually fairly simple to do now that we have this compile node function, because we can just loop over the child nodes and recursively invoke compile node for each of them. So for each child node, the process of collecting directives and applying them begins again. And what we end up with is a depth-first tree traversal of the DOM tree, where we visit every node, collect directives, apply them, move on to the first child. And when we're done with that whole tree, we have compiled the DOM. And that's how compilation happens. Which brings us right into the next topic, which is the linking of directives. So what we have here so far is more or less like, it's pretty useful by itself, but it's more or less just a jQuery replacement where we match this JavaScript code to these elements. But where we start to bring Angular more into the discussion is where we start to talk about linking, because linking brings in scopes. And we know how important scopes are to Angular application architecture. Well, at least Angular 1 application architecture, because that's where we put our application data and functions so that we can share them between templates and controllers and directives. And scopes are where watches are, so that's where the change detection mechanism is implemented, watches and digests and apply. And scopes bring in also the event system, because that's where you emit and broadcast the events and listen to them. So scopes bring in a lot of the rest of the Angular framework to this discussion, and the process of combining scopes to elements is called linking. So we need to extend our picture of what we mean by this compiler a little bit. So in addition to what we already saw earlier, we have another output from that compiler, which is the actual linker for that specific compilation. And that's another one of these processes that has its own inputs and outputs. So the linker has its inputs as the compiled DOM from the previous step and a scope object, and it combines those two to produce a linked DOM. And what's really tricky about this is that there is no link service in Angular that you could inject and call. Instead, the linker is always an output of the compiler. And it's a bit an interesting way to do it, and we'll see how that happens. So now we can have directives that have link functions on them. So here's one, takes a scope and an element and does something with those two. So in this case, it just adds a CSS class still to the element, but in this case, the class name is actually dynamically defined by the scope. So it's kind of an input to this directive. And as you see in this case, the link function is a return value of the compile function. That's kind of the most low-level way you can make a directive link function. There are shortcuts to that, but they all kind of build on this implementation. And then how you actually do that linking is when you call the compile function, you need to grab the return value from that, because that's going to be the link function. And then you can later call that link function, giving it a scope as an argument, and it will do the linking for that same DOM that you originally gave to the compile function. And that's how those two things connect. So we now expect compile to return something, which is the link function. So we add this return statement here. And in compile node, we'll actually make that link function. So we return this new function called the node link function. That takes a scope, and its job is to now link this node. So what does that actually mean? Well, linking a node really doesn't mean anything more than just calling all the link functions of all the directives that we have found for this element. And before we can call them, we should collect them. And we can do that during compilation. So we'll introduce another array here called link fns. And into this array, we can collect the link functions. And we get them by grabbing the return values of those compile calls for those individual directives and put them in this array. So when we're done, we have this array of link functions, one for each of those directives. And when we have that, once we get to the linking phase, we can just call them. So we can loop over those link functions, and for each one, call it with the scope and the element. And that's where the directives link function gets called. So in between of the compilation and linking, the link functions are sitting, waiting in this sort of function closure as internal state of this node link function. It remembers which link functions it should call once it finally gets called. And that links a single node, but again, we need to also do the descendants as well. And the key to that is to look at how we have this recursive invocation of compile node here in the compilation phase, and that compile node now returns this node link function. So actually, if we hold on to the return values of those recursive calls to compile node, that gives us an array of the node link functions, one for each of the child nodes of this node, and we can do that using map. So then we can call those two during linking. We have another array which we can loop over and call each of those functions inside. And what this is essentially the node link function recursively invoking another instance of itself for its one of the child nodes. And you may have noticed that we actually call the child link functions before calling the link functions of the element itself. And that's because what we have here are so-called post-link functions. And the definition of post-link is that it's a link function that's called after child nodes have been linked. And that's linking, a simplified version of it at least. It's pretty grossly simplified in the sense that if you think of it, we give the link function a scope object, and then it uses that scope for everything. There's just one global scope in the whole application. And I think we all know you usually don't have just one scope in your Angular application. You have a hierarchy of scopes that begins from the root scope and has any number of descendants that come and go during the lifetime of the application. Furthermore, this hierarchy often sort of mirrors your DOM hierarchy, so you have these two trees that have similar shapes. And that's because you have directives applied in the DOM that cause new scopes to be created. And you end up with these two trees that have similar shapes. ng controller is one of those directives that cause new scopes to be created. So how this happens is you have directives which ask for new scopes or inherited scopes for them by providing the scope attribute with the Boolean true as the value. And then when that happens, the scope that the directive gets linked to is not going to be the global scope or the parent scope anymore. It's this element's own scope, and it can put attributes on it and be quite sure that it's not going to clobber attributes on the parent scope or sibling scopes. So it's just a little bit more modularity into this thing. So to implement this, we are going to have to, during this compilation process, check if we have any directives here that want new scopes to be created. And we introduce this new variable for that purpose. So then as we go over these directives, after we have compiled each one, we check if it actually has a truthy value in the scope attribute. Because if it does, it's asking for a new scope, and we put it in this variable. And we also only allow one of these per each element. So if we already saw one of these for this element, we actually throw an exception during compilation. So you can't have more than one scope on, more than one directive on an element that wants to have a new scope. And you've probably seen an exception if you've used directive much that complains about that. But now we have this variable new scope directive we can use during linking. Because when we get to the link function, we can check, was there a directive for this node that wanted to have a new scope? If there was, we can just make a new scope. And we do that by calling the new method on the scope that we were given. And then we use that scope for everything from that point on. It's used for all directives on this element and on all child elements, so that it actually replaces the parent scope for this DOM subtree. And that's how we end up with these parallel hierarchies, because of this recursive kind of scope replacement that happens. And that's inheritance. It's sort of kind of a simple concept, at least when compared to the next one, which is isolated scopes, which is a little bit more involved. And we'll use the remainder or I'll use the remainder of my time for that. So isolated scopes, we should define those first. An isolated scope is in some ways pretty much like a regular scope in Angular, in the sense that it's like any scope part of the scope tree. It has a parent in that tree. It participates in digests. It propagates events up and down. So it's like a normal scope, except for one thing, which is that it doesn't actually share any of the data with its parent. So if a parent scope has an attribute, an isolated child scope won't have it. And that's because we skip the creation of that prototypical object inheritance that happens with regular scopes. What you can then do instead is to create these case-by-case isolate bindings, where you say, I want this expression to be evaluated on the parent scope, and its value be bound to this attribute on the child scope. And in that sense, kind of do this sharing of data on a case-by-case basis instead of sharing everything through inheritance. And that's sort of like passing arguments to the scope, or you can think of it as something like that. And how that looks like when you use it is you have these directives that have the scope attribute, but this time the value of that attribute is not a Boolean, but an actual JavaScript object. That object may be empty, but it also may have contents on it. If it has contents, those are going to be the specifications for the bindings that should be set up for this directive. And how those work is that each value in that object should match an attribute name in the DOM where the directive is actually used. And the keys in that object line up with keys that end up in the actual scope that the directive gets linked to. And the net result is that you can have expressions defined by the directive user whose values are bound to the isolate scope. Again, it's kind of like passing arguments to the directive. So let's do this as well. We need one more tracking variable here to track if we see any directives that want to have an isolate scope. And then as we go over the directives during this compilation, we'll check when we see a TruthIsScope attribute, is that value actually a JavaScript object? Because if it's an object, that's an isolate scope directive. And if it's not, it's a regular inherited scope directive. And that affects which variable we put it in. And we still only allow actually one of these per element, so you can have either an inherited scope directive or an isolate scope directive for a node, but never both and never two of the same, or you'll get an exception during compilation. So we have this tracking variable, which we can again use during linking. So we'll see here, did we see any directives on this element that were asking for an isolate scope? If we did, we create one, again by calling the new method on the current scope, but this time passing in the argument true, which tells it, please also isolate this scope. What we don't do, however, is we don't replace the parent scope with the isolate scope. We introduce another variable for it. And that's because we should not use this isolate scope for everything like we did with inherited scopes. We should actually use it for one thing only, which is to link the exact directive that was asking for the isolate scope. So if there are any other directives on this element, they should know nothing about that isolate scope. It's just for that one directive. So when we go through these link functions here, we should know which link function came from the directive that was the isolate scope directive. And for that purpose, we need to do a little bit more bookkeeping, which is when we get these link functions from the directives, we put in a reference to which directive each link function came from. And that's just for our internal bookkeeping purposes, because now we can check back in the linking function when we go over these link functions, was this link function's directive the isolate scope directive? Because if it was, only in that case do we link it to the isolate scope. Otherwise we link it to the surrounding scope. And that's how you target that scope to be used for this one directive only. Now, that pretty much takes care of the creation of isolate scopes. What we don't have there yet, and which is the last thing we'll talk about, is these isolate bindings. So the scope is currently completely blank. There's nothing in it, which is often useful, but we should support these bindings too, which the user can define. So to do that, we do this right after we have created the isolate scope itself in the node link function, where we actually go over all the specifications for the bindings that there might have been in that directive. And for each one, we execute this function where we will actually set that binding up. So if you recall, the values in that spec object were these strings that begin with the equal sign and are followed by the attribute name that we should be looking at. So the first thing we do is we actually grab the attribute name from that string by actually extracting everything from it except for the beginning equal sign character. And that gives us the attribute name we should be looking at in the DOM. And we do that with a regular expression and a group. That's going to be a camel-cased attribute name, whereas in the DOM, we don't use camel case, we have hyphen-separated strings, so we need to denormalize that. And for that, we can use Lodash again, which has a kebab case function for this purpose. So this is a function that turns a camel case string into a hyphen-separated string. And now we have the attribute name we can ask the DOM that the matching attribute value for. So we have this element that we are currently linking in the scope. So we can simply get its attribute value for this denormalized attribute name, because that's going to give us the expression that the directive user has defined, which is the expression we should evaluate. And what we should do is evaluate this expression in the context of the parent scope, get the result, put it on the isolate scope, and keep that in sync over time. And as it happens, the tool for that is already handy to us here. That's watch. So we can simply watch this expression on the parent scope and have a listener function that takes the new value whenever it changes, puts it on the isolate scope with this attribute name that was specified in that binding spec. And there we have bound the attribute. So now it's kept in sync on that isolate scope over time because it's taken care of by the change detection system. And that's binding, though there is one more thing, which is that if you've ever used these equal sign bindings on isolate scopes, you'll know that what they are actually two-way bindings. And that has a specific meaning to it, which is that not only should we be watching the parent expression and bind the value to the isolate scope when it changes, but we should also watch the attribute on the isolate scope and propagate that back up when it changes. So the data flows in two directions. That's what two-way binding means. And actually, as far as I know, Angular 2 will not do this. It will have just one-way data flow, but Angular 1 does do it. And here's how it does it. So before we actually do that two-way binding, we need to refactor our existing code just a little bit. And first of all, we're going to parse that expression we got from the DOM using the internal parse service that Angular provides, $parse. So we inject that into our compiler. And then when we get that expression string, we give it to that parse service, which will give us an expression function, a regular function that evaluates that expression for us. Then we'll make a sort of alternative implementation of this watcher that we have here. This is going to be a sort of special watcher in the sense that we don't actually put any listener function to it. It's just a single standalone function. It's kind of like just a callback to the digest. So Angular will call this function for us whenever a digest occurs. And inside this function, we can do anything. And what we do is our own little change detection. So what we do is we evaluate that expression function we now have on the parent scope, which gives us the expression's value, the current value. And then we look up what value we have currently on the isolate scope for that binding, and we compare those two. Because if they are different, there has been a change, and what we need to do is put that new value on the isolate scope. So what we end up with is this watcher that is functionally equivalent to this previous watcher. These two watchers do exactly the same thing. It's just that the new one is a little bit more low level. We do our own change detection there. So we can get rid of the old one, but on the new one we can now build that two-way data binding. And the key to that is to introduce one more tracking variable, which is called parent value. And that variable will always hold the latest value we have seen the parent expression to have. So between digest, we remember what did we see as the value of that expression on the parent scope. Because once we have that, we can check this when we actually detect a change where the parent expression value and the child value are different. We can check, is the new parent expression value different from the previous one? Because if those are different, the parent expression value has changed. And we need to do what we did earlier, which is to put the new value on the isolate scope. But if those two are the same, and we still have detected a change, that means that the value of the attribute on the isolate scope must have changed. And here's where we need to do that other direction of the two-way data binding. And for that, we have a trick that Angular provides to us through that expression function that we got from parse. Because Angular expression functions have this method on them called assign. And that's a method that evaluates the expression in a special way. So if you have an expression like foo.x, when you pass it, you get an expression function. And when you evaluate that function, you get what you expect, like the equivalent of saying return scope.foo.x. But you can also call a method on it called assign, give it a scope and a new value. And what it will then do is it'll go into the expression and figure out how to replace that value on the scope with a new one. So this is something the expression parser in Angular provides us. And we can use that here because we have the expression function, we have the parent scope, and we have the new value from the isolate scope. So we can just assign it. So that's how we send it up to the parent scope, and that's how we do that second direction of the two-way data binding. And then all that's left for us to do is make sure our tracking variables are correctly set up for the next watch iteration, so our parent value matches whatever we just replaced it with. And yeah, that's how two-way data binding works in isolate scopes. And that's actually what I wanted to share. So hopefully this gives you a better idea of what actually happens when Angular starts, how it compiles the DOM and instantiates those directives, how the link functions get called on directives, how do scopes get created during that process, and how these isolate bindings are created and how do they work. And that hopefully makes the Directive API make a little bit more sense. So that's what I had. If you have anything you want to discuss or ask, I'll be around right now behind there on the second room and for the rest of the conference. Thank you.